truth table for conditional and biconditional. Here we have self-contradiction. It's a compound statement that is always false. A tautology is a compound statement that is always true. And implication is a conditional statement that is tautology. I'm going to write what we should have for each one of these. The first one, self-contradiction, is compound statement that is always false. What that one means, meaning that our last column of truth table, we should have all false. Tautology, and this is always true. The last column is all truths. And implication is a conditional statement that is tautology, meaning that here we have if-then statement, and also the last column, all truths. Now, example number 1, construct truth table for the following statement. We have if P, then Q. How we read it, we usually say P implies Q. I'm going to write the rule for this part. The only time that is not true is when we have true implies false. So this is false. When our P is true, but Q is false. Again, the first column, we have all truths first, and then we have all false. Here again, true, false, true, false. Now finding the answer, the only time that this one is not true is when first we have true. I cannot have true implies false. So P implies Q, we have true implies false. So this part is false. That is the only one. So all these are true. Part B, we have P if and only if Q. This one is same as having P implies Q, Q implies P. So this is what we have on this part, and that is P implies Q, Q implies P. So we combine these two to have what do you have on top here for if and only if? This means we are going to use same rule that we did for if then statement. On that part we said we cannot have true implies false. So true implies false. I cannot have that part. That is same for this part here. True implies false. So this is one-way arrow, and our arrow moves from right to left. So we have to start reading from right to left. In this case, we have true implies false. So for both of these, the answer is false. This means the rule for if and only if, the only time that the answer is true is when you have true, true, false, false. So we should have exactly the same thing in order to have true. Meaning when you have true, true, your answer is true. When you have false, false, your answer is true. This one is true, true. So the answer for this part is true because we have exactly same answer for P and Q. The other one, we should have the same thing. So this one is false, again false, meaning the answer for this part is true. But what I have here, this one is true, the other one is false. Same thing for third row, we have one is false, the other one is true. If I say using conditional statement using if then, we can explain this way, that true implies false, that is wrong. And this one, true implies false, again, that is not true. This is false. But we're not writing that way because this one is not if then, this is if and only if. But how we can explain is this way. Okay, so this one is false, false. So that's the final answer. So this one we have 3 letters, PQR. The number of rows we have 2 to the nth power plus 1. So here we have 9 rows. So first writing all these, true, false. Now the fourth column is based on the second column, and we have to use not. So not true, we have false, not true, false. not false, true, not false, true. Repeat. Now here is negation, Q and R. So the rule was that when you have two truths, the answer is true. So this is true, true, and here we have true, true. If not, your answer is false. We have P implies this column. So I'm using one-way arrow to show that we started with the first column P and using the fifth column. That part is what you have here on this part. And the rule was we are not able to have true implies false because the answer for that part is false. So the first one is true implies false. Here again, true implies false. True implies false. So these are false. And all others true. So true implies false. That is false. False implies true. This one is true. Here again, we have 3 letters, so it's 9 rows. Okay, now next one is negation P. Okay, so here again we have negation, and that is for R. Here we have Q or negation R. So it's Q, negation R. We have to use the second and fifth column. So for or, the only time as false is when we have false, false, this is false. So again, we have false, false, this part is false, and all others are true. And finally, negation P is this one, if and only if, this part. Fourth and sixth column. We should have exactly the same thing. We should have true, true, false, false to have true. If not, the answer is false. So we have false, true. This one is false. False, true again. Here is false. False, false. We have same thing. So that is true. False, true. False. True, true. It's same. So we have true. Again, true, true. True. True, false. False. And finally, true, true. Again, we have exactly the same thing. So this is true. That's what we have for this rule. So true if and only if true is true. False if and only if. False, we have true. If and only if. So this is false. And finally, this one true. If and only if. False, this is false. So here again, we have to write in symbolic form and then construct truth table to find the answer. For this part, I'm going to use PQR. We will advance tournament if and only if James plays or Fondo doesn't show up. So the first one, for the first one, I'm going to use P. We will advance tournament. We have if and only if James plays. Here we have not, meaning this part is negation R. Now writing symbolic form. We have P if and only if. Q, we should have this one first. Here we have comma or negation R. So first we have this compound statement before using comma. Now we have negation R. So this negation R is based on third column. We have true, so it's not true, it's false. It's not false, it's true. Repeat. Now P, if and only if Q. So in this case, you only should have same thing, exactly same thing. So either true, true, false, false. These are true. If not, the answer is false. So we have P, Q. So the first one is true. Here is true. That is true. Same thing here. This is false, false, because we have true, false, true, false. Again, we have false, true, false, true. And here on this part, we have false, false. Exactly same answer. So we are going to have true, true. Here, P, if and only if Q or negation R. So we have or in between. We should have at least one true. So the only time it's not true is when we have false, false. So this is false, false. Here is false, false. So this was the final answer for this compound statement. Okay, now part B, here we have it template. Then we can go fishing if and only if the pole is not broken. Again, we have to assign letters. Here again, we have 3 letters. On the first part, we have if then statement, and then we have if and only if. And this part we have comma in between. And here is not. I'm using P for that part. Here Q. And pole is broken. That one's R. Okay, I'm writing that part here, symbolic form first. We have if then statement, so it's P implies Q. This comes first. We have comma, if and only if. Negation R. And how many columns we have? We have 3 letters, we have negation, so it's 3, 4, 5, and 6. So first writing all these. We have P implies Q. So the first column implies the second column. And finally here, so in this part we used if then statement. But in this part, we have to use what we have in between is if and only if. So is this part P implies Q, if and only if, negation R. That is the final answer. Remember that the following is a tautology, self-contradiction, implication, or neither. So we had this part here on top. Said for self-contradiction, we should have all false for the final column, for the final result, and tautology, all truths. The implication is when we using if-then statement, and the answer are all truths. So it's same as tautology, but using if-then statement. So the first one, we have PQ, we have 2 letters. That is same for part B, we have PQ, 2 letters. So this means we have five rows. And how many columns we have? We have PQ, 2, 3, 4, 5, 6. So we have 6 columns. So third column, we have negation P. False, false, true, true. We have negation Q, fourth column. It's based on this one. So false, true. Now fifth column, negation P or Q. Now here we have if and only if. And it's based on this one and here. So here is our final answer. False, 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 true. And here is asking which one is as to these, which one of these that we have here on top, tautology, self-contradiction, or implication, or neither. As you can see in the final column, we don't have all false, we don't have all truths. That means the answer for this one is neither of these. So we don't have tautology, we don't have self-contradiction or implication. So this probably have or, but this one is if then. Negation Q. Now the fourth column is negation Q implies P. The only one that is false is here we have true implies false. Now here the final answer, we have or in between. And this is this one and this part here. Using or. So for the final answer, we have all truths. Now we want to see which one applies to this part. Is tautology, self-contradiction, or implication. We have all truths. So either tautology or implication. But the point is, what we used to find the final answer was or in between. We didn't have if then. And now I want to see if do we have tautology or implication. For implication, we should have if then statement. We cannot say that this part was if then. So that's why this is implication. No, that is not true. We have to work based on what symbol we used to find the final column, the final answer, the last column. The one that we used here was in between, we had or. So this is not implication, this is tautology. On this part, we have P, Q, 2 letters. Here is negation P based on this one. It's false, false, true, true. Fourth column, we have P and Q. The fifth column here is based on what they have here as negation. It's false, true, true, true. And finally, last column is negation P implies this part. We have false implies false is true. False implies true is true. True implies true, true. True implies true, true. So here we have all truths, and this means we should have either tautology or implication. So we have implication because of using if then statement.